This is Spare Time Repair, and this is an NAD C 521BEE. This was sent to me by Donald, who explained that the tray doesn't always work, but even when it does, the disc won't spin up and the display just flashes. This looks like a simple belt problem to me, but I also think that that display should have a backlight, so I'll be looking to restore that as well. When I first saw Donald's photos, I imagined this unit was from the 90s, but it was actually made in 2003. The NAD look isn't for everyone, but personally I'm a fan of it, and a digital output adds to the appeal of this model. I'm not anticipating any big problems here, so let's make Donald less sad about his bad NAD. I mean, it is technically NAD, but everyone calls them NAD, don't they? I think this has got a Sony pickup in it. Pretty common for NADs, I think. Well, it's a bigger PCB than I was expecting, but I don't like these non-removable transport contacts. I think they will unplug from the transport side, but still. Yeah, we've got a KSS213C in here, and there's supposed to be a PCM1710U DAC in this thing, but I can't see it, so it must be one of these on the underside of the board. Anyway, let's get to that belt change. Yes, I remember this now. We have to pick out this piece in the corner, which is operating the leaf switch. And then we need a couple of toothpicks to open these clips at the bottom. And I should be able to do this without removing the transport. Actually, I think this bit slides off once you remove this gear. Well, I think I can get the belt off anyway. Oops, it's not misshapen, it's just a bit slippy. There's no grip left on that at all. There was a bit of grease on this, so I'm going to clean up the pulleys first. Drying off that channel with a mini swab before I put the new belt on. And I think that's all we need to do. Of course, we should always clean the lens. Sled rails feel clean. I should just oil the spindle motor. And these clamps are keyed so that you can't get them on the wrong way round. It's just not going to work. So I'm pretty sure that will get us playing again. And for 2003, I'm going to go with some Clear Lake. Yep, we now have no disc on the display, which it wasn't doing before. Ooh, still no go. So I guess that belt isn't tight enough. Well, it's probably tight enough, it's just not beefy enough. Needs a bit of torque to lift that mechanism up fully. I mean, it seems to go up fully without a disc. Well, a 2mm belt feels like overkill, but maybe that's what it needs. Ooh, that's a little bit tight. That one's slightly bigger. This is the winner, I think. Yeah, that feels good. Okay, take two. Nope, that one's too tight. In fact, I think I just didn't have the tray installed properly because it wasn't sliding like this, it was sort of facing resistance. So I'm going to leave that thicker belt in and try it again. Oh, third time lucky. Yes. It's struggling a bit. Don't know if that was just because it was on random, but it took a bit longer to find the track than it should. No, it's struggling again. Well, maybe there's a tracking adjustment I can make for that. Gets there in the end. So, semi-fixed. I think I'm going to look at that backlight next. Well, I say I can make an adjustment, but I'm used to older machines. This is 2003 and there are no adjustment potentiometers on the board. Everything was done automatically. No, I told a lie. There is one potentiometer down here. I'm not sure what it does. I'll have to look up the service manual for that. But not before I've removed the front panel, which has 5 screws in the top and another 5 in the bottom. I feel that was a little unnecessary in the bill of materials. It's times like this when I feel I should invest in an electric screwdriver. I've got a couple of clips. I think I need to take the faceplate off. At least these ones are removable. Just checking that I can't get them mixed up. Might as well remove everything. Could do with a clean. Again, did we really need 8 screws in this little PCB? Just the 3 in this one. Well, the backlight's not going to be as easy as I thought. I assumed we'd have an incandescent bulb along the top here, but not so. I'm not really sure cleaning is going to improve this much. I think it's mainly scuffs, and this corner's been dented. But now I've stripped it, I might as well, after I've undone another 8 screws that are holding in these buttons. The front panel does look a bit better, so it was worth doing. And I did find the service manual, and the backlight for this display is actually an EL panel, which is an electro-luminescent panel. It runs on about 100 volts AC to provide an evenly distributed backlight, but they do get dimmer over time, and clearly this one has failed altogether. And it looks like this is the separate connector for it, which plugs in here, and it's labelled ground and EL01. So let's measure that AC voltage, and I'm only going to use one hand. Wow, 175 volts. That sounds a lot. An EL panel is basically a capacitor with phosphors in it to emit the light. So we can actually measure the capacitance of it. I'll do that with my Finalizing LCR tweezers. And we're looking for around 50 nanofarads. And we're only getting about 6. So I think that confirms that this one is basically toast. I'm wondering how to get my replacement lamps in here. I think the first step is to desolder the panel itself. So we've got our display, a very thin diffuser, and this is our EL panel, which I also need to desolder. Well, that answers my question. We've got plenty of room behind now to get the LEDs in, although diffusing them at that distance is not so easy. Incidentally, you won't be able to hear it, but this is the inverter for that 175 volt supply, and there's a very high-pitched whine coming from it. It doesn't operate at normal AC line frequency, 60 Hz. It's much higher than that, and since we don't need it anymore, I think I'll be removing it. And that potentiometer we saw earlier is, I believe, the voltage input adjustment for the inverter. And in my tray of LEDs, I do have this. It's a small LED strip that operates at 4.5 volts. And it's not going to give me perfect distribution, but it's going to be better than individual LEDs. It's also very low profile. And to be honest, I've been waiting for an excuse to use it. So I'm feeding it with 5 volts from my bench supply here via this 330 ohm resistor. And the individual cob LEDs are pretty obvious, actually more so to my eyes than it looks on the camera. And that's just going to look terrible. I mean, it's no surprise they went with the EL option. I wonder if I can diffuse that sufficiently. I think the best thing to do would be to remove this piece of metal here, which is just there to provide a bit of support, and then mount the LED strip at the top here. And maybe I can put some foil behind here, obviously protecting these jumper wires. I mean, it doesn't look like it's doing anything there, but with something reflective, maybe it will. Well, this is my final solution. Put a piece of white paper behind it, which actually works better than aluminium foil. angle the LED strip from the top, and if I lay this over it to light up some random segments, I think they're actually going to be okay. Obviously it's not as good as it would have been originally, but an improvement on what we had. And I just attached that strip to the top of the PCB with some hot glue, which isn't very elegant, but it feels quite secure, and I did check there was enough clearance. And for a 5-volt power source, or close to it, I can use this, which is for the power LED on the front. And it looks like it's coming from this jumper here, so I can just tap onto that. But first I ought to remove this inverter for that EL panel, which means removing this whole PCB. Again, they didn't skimp on the screws. Need to be careful with these fixed connections. Here's our DAC hiding underneath, as I thought. The Burr Brown PCM 1710U as the Sony DSP, but this is what I'm interested in, so I'm just going to desolder it all together. Stuck down with something. No more high-pitched whine from that thing. Now I can repopulate the front panel. And I've put the connections for the new LED strip through the original holes for the EL panel and solder them onto the original pads. So I can just cut this connector off and solder it straight onto that jumper. I left this out. I couldn't really see the point of it. It's not a polarizer. It's just unnecessary. I'm just going to put a couple of screws in now in case it has to come off again. And in fact it does, because I've squashed that lead underneath here. I wondered why it was tricky to get back on. That's no good. That's better. Tin that wire up. I've screwed up here, haven't I? I should have left this plug on and just run a jumper from this connection to the original socket. That way I can just plug it straight back in there and it's removable in future. Well, I can still do that. I just need to reattach the plug. That's a much better solution. So once again, I've taken out the main PCB and this is the connection that I want to tap into. And the only places it goes is this test pin here and this pad for the inverter. So if I tap my 5-volt supply in there, and the ground can go in there. So this is my supply, which is actually 4.28 volts. Well, I suppose I could go direct onto these pins, just in case someone wants to refit the inverter in future. I'm just going to clean this board up a bit. I'm guessing this is residue from the wave soldering process. And I just did that so that I can run a bit of Kapton tape across this wire. A bit tight for space here. Just trying to make sure I don't trap any more cables. Oh, and this is the cut-off plug that I've resoldered onto those wires. And for all the screws in this board, there aren't anywhere you need them the most. This piece where you're putting back the connectors is really flexy. So I'm having to get a thumb under here so I don't damage anything. But I think we are now fully back together. So will we now have a display backlight? Oh, well we did briefly. Well, that shared load has pulled the voltage down, because we've got our 4.28 volts here on this jumper, but here it's now 1.95, and here where we need it, it's also 1.95. Even with my new LED strip disconnected, this power LED connector is now still only reading 1.95 volts. I'm sure I measured it earlier and it was 4.28. This resistor is dropping it. But maybe there's not enough current on that supply. I guess it would make more sense to use the original power supply for the inverter. That's going to be a higher voltage, probably 12 volts, but I can just use a larger resistor. Well, after all that, it was actually a grounding issue. By removing the inverter, I'd broken the ground connection to that socket. So I've restored that with this wire here, but in the meantime I'd changed my source to this more reliable 5-volt regulator, and I've connected onto this capacitor on the other side of it, which is smoothing out the voltage. This is the regulator, this is the capacitor. And so finally, I think we should see a backlight. And no, it's not the most evenly lit, but short of getting another EL panel, I'm not sure what else I could do. Well, we've still got those tracking issues. It plays fine once it's locked onto the track, but finding it is sometimes a problem. So I wonder if we could resolve that by servicing the transport a bit more. Let's disconnect this thing properly. This connector is being very stubborn. And it could be a problem with the sled motor. Certainly worth giving it an oil. I didn't do it earlier because I couldn't access it very well. It's got this shroud over it, but this gear should pull off. In fact, we have to nip it together down here. And this shroud here has 3 little clips underneath. Doesn't look like we've got any missing teeth, but I might desolder this motor because in situ it's actually quite hard to get any oil in there. Sled's moving quite easily. As you know, I'm always reluctant to blame the pickup. It's worth ruling out other issues first. And measuring the resistance of this motor while I turn it, it does seem to have some flat spots. So I'm going to remove it from this little board. And I did mark the positive terminal, and I'll just let that run from the bench supply for about 10 minutes. I ran it for about 20 minutes in the end. I think that's an improvement. Well, I should be thorough, shouldn't I? It looks like I've got to remove these 4 screws to get the sled rail out. Well, this looks a little bit crusty. I can actually remove this piece. Well, I think that's as smooth as it can be. So let's see how it behaves now. So we're keeping an eye on how quickly it can find the tracks. It's still a problem. Sorry, that's just not good enough. Well, I thought I'd check the eye pattern, and it's probably the worst one I've ever seen. It's completely clipped and barely visible. So this is kind of pointing to a bad pickup, I think. And it's not my LED mod, because I've just disconnected that, and we're getting the same pattern. Well, I just turned down the laser power potentiometer, and that eye pattern is looking a lot better. It's no longer clipped. So I would imagine that Donald or somebody had turned it up trying to get the disc to read in the first place, and it was just far too high. Because now it's seeking perfectly. I'm glad I made that adjustment because I think that laser diode would have burned out pretty quickly if it had been left alone. And here is that potentiometer, and I marked the position of it before I started, so you can see how far I had to adjust it back. It was almost maxed out at this point. I'm surprised it was working at all when it was cranked up like that. I'm going to leave these parts inside the machine with a little note, just in case anyone in future wants to restore them for some reason. I expected that one to be a lot easier than it turned out to be, but it shows that you can't take anything for granted. After a bit of reflection, I decided to swap the pickup for a new one, since I couldn't be sure I had that laser power adjustment in the right place. It's not performing any differently, but I think it gives it the best chance of being a lasting repair. I also found that you can buy replacement EL backlights, but I think getting rid of that high voltage inverter is a better option. Donald didn't even mention the backlight in our emails, so I hope he'll be happy enough. But that's it for now. Thanks for watching, and I'll see you in the next one.